For this video we are looking at the idea of circular motion and what it is that is needed to keep an object moving in a circle. Now the first example I've got is a ball on a string. So imagine you're looking from above, there's a piece of string and a ball, and maybe somebody's spinning that ball so it's moving in a circle. Now I've said this ball is moving at a constant speed, and that's the example we're going to work with. So we've got a ball on a string moving at a constant speed in a circle. Now there's a tricky little thing that you have to really be able to talk about, and that's the idea of the acceleration. Acceleration is a change in velocity divided by time, and as you know, velocity has a direction. When we're talking about velocity, it's very similar to speed, only velocity has a direction. Now if you think about the ball at this moment in time, if you took a snapshot of, as we've just done there, at this moment in time that ball is actually moving in that direction there. But if you had a look a little bit later on, when the ball moves around the circle a bit, the direction changes, it's actually moving in that direction there. And because that direction is constantly changing, the velocity is constantly changing, and if the velocity is constantly changing, we have acceleration, even though the object is moving at a constant speed. So it can still move at a constant speed and be accelerating at the same time. Now the other thing that's quite tricky is if we were talking about the direction of acceleration, we might be tempted to talk about accelerating in a circle or something like that, but in actual fact the direction of acceleration is towards the center of the circle. It's a little tricky point, but you have to remember that the acceleration is, this object is continually accelerating, but it's accelerating towards the center of the circle. I've got a note about that later on, which I'll show you on a slide, but that's a point that you've got to understand. So we have the acceleration towards the center, but what's causing that acceleration? We need a force for that acceleration to happen, and we actually say we need a resultant force, an overall force, and that force has a special name. It's called centripetal force, and that force acts towards the center of the circle as well. So the centripetal force here is acting towards the center of the circle, and it's the resultant force that keeps this object moving in a circle. Now without that centripetal force, if that centripetal force disappeared, this object would just shoot off in a straight line from the point wherever it is at that time when the centripetal force stopped. Now the next thing we have to look at is actually, in this case, what's actually causing that centripetal force, what's causing that resultant force towards the center. And for this example, it's the tension in the spring. There is tension in the spring that is causing that centripetal force, which in turn is causing the acceleration in a circle. So there's a couple of tricky points there that you need to know and remember. I've got a slide at the end which summarizes all of it, but this is really the reasoning behind it. A couple of other examples. We've got a satellite orbiting the Earth. Obviously there's no string here holding the satellite in place, but again we must have centripetal force to keep that object moving in a circular motion. And what is that force for this example here? It's actually gravity, and that again acts towards the center of the Earth here. Here on the right hand side, this is supposed to be a skater. I couldn't draw a skater very well, so I just drew this little blob. So we've got this skater going in a circle on some ice, and again there's not a piece of string holding this skater there. So what's causing the centripetal force here? In this case is actually friction between the skates and the ice, and again that friction acts towards the center of the circle. Seems a bit strange to talk about it in that way, but actually is acting towards the center of the circle. So one other example is a car, and again this is similar to the skater. It's moving in a circle, and if it's going to keep moving in a circle there must be a centripetal force, and in this case what's causing that centripetal force towards the center? Well, again it's the friction of the tires on the road, and that's what's causing that particular force there. And you should be able to give an idea of what the force is for a variety of different examples, and remember the acceleration is towards the center as well, and for this object to move in a circle, in fact for any object to move in a circle, we need a centripetal force. Now the last thing I just want to quickly go through is what things will change the centripetal force needed to keep an object moving in a circular motion. Well, there's three things that you need to really focus on. The first one is the mass. So if we had a car with a bigger mass, then that means we would have to have more centripetal force in order to keep it moving in that circle. This force towards the center would have to be greater. Also the speed, so if we've kept the mass the same but we increase the speed of the car, so somebody inside there pushes the accelerator, increases the speed, then we would have to have again a bigger centripetal force in order to keep it moving in a circle. Otherwise this car would actually just skid off the road. In fact, it will skid off in a straight line in this direction if the speed got too high and if the centripetal force wasn't enough to keep it moving in a circular motion. Also, if we decrease the radius of the circle, so we've got the circle here, if the circle radius is decreased, we need a bigger centripetal force in order to keep that moving in a circular way. Okay, so some quite tricky points there, but in summary, these are the key things that you need to know. An object moving in a circle, it accelerates towards the center of the circle. The direction is constantly changing but not the speed. We've got the resultant force called the centripetal force, which causes the acceleration. These three factors affect or increase the centripetal force needed, and basically this is an overall summary of what you need to know. So it might be worth going over this video a couple of times just to make sure you've got the points, but other than that, that's me done. Thanks for watching, and I'll see you again soon.